In this section, we'll be looking at the proportions between areas and volumes of similar solids. Now, earlier we looked at the ratios between areas and scale factor, and notice that's what we're starting with. If we look at the ratio of areas based on the scale factor, we just square it. Well, volumes, we're going to cube it. Remember that scale factor is always about the ratio of the side lengths, whereas the ratio of the areas would be about area and the volumes about their volume. So if we want to know if two rectangular prisms are similar, the definition of similar would mean that all of the corresponding lengths are proportional. So we would need to check here. Here what they've done is they've checked corresponding sides. So the biggest side here is 3. That would match with the 6 here, so 3 over 6. Then the next one, 3 and 6 again, which they have over here. And then the smallest side with the smallest side, 2 over 4. All of those simplify to 1/2. So these shapes are similar because all their dimensions are corresponding, and so the two figures are proportional and they have a scale factor of 1/2. Now, using that scale factor of 1/2, if I want to know the ratio of areas, we take that 1/2 and we square it. So the ratio between the areas will be 1 to 4. This larger one is 4 times the larger one. If we look at the ratio of volumes, we're going to take that scale factor 1/2, and we're going to cube it, which will give us 1 over 8. So our volume is 8 times as large. For the next figure, looking at our dimensions, we would match the 2 with 3, which gives us 2/3, another 2 and a 3, which also gives us 2/3. But notice the 3 and the 6 would give us 1/2, so these are not equal, and so these are not proportional. Okay, one way that we can use the scale factors in this problem, notice they give us information about the ratio between the areas. Then they also give us the volume of a smaller can here, the smaller one here, and they want us to find the volume of the larger can. So the first thing we need to do is find the scale factor. Now remember, our scale factor, if we square it, will give us the ratio of the areas. Since they've given this as our areas, I'm going to write it as the big area over the smaller one would be 1019. We can even leave the units in here. That might help us with these, over 425. Notice since these are squared, what I want to do is take a square root in order to get my scale factor. Now these don't work out nicely. These are going to give me some decimal values. The top one will come to 31.922. I'm keeping a lot of decimals. Also notice that centimeters squared, the square root would be centimeters, so that helps us know that we're on the right track. And so that scale factor would be these decimals here. Now if we want to find the ratio of the volumes, remember that our volumes would take the scale factor and cube them. So I'll take my scale factor from up here. I'm sort of canceling out the centimeters here. But what I want to do is cube this. And if I did leave the units, they would be at centimeters cubed now, because they're cubed, but I want this as a proportion. Now I could also divide this and set it equal, but I'm going to leave it like this just so I can set up a proportion using the ratio of the volumes. Remember what we were asked to find. We were asked to find the volume of the larger can, which would be this volume. So the volume of the big can divided by the volume of the smaller can, which was given to us as 1157 centimeters cubed, is going to be equal to this ratio here. If we cross multiply and divide, we're going to end up with the volume of the big one, about 4,295. I'm rounding to the nearest unit. And then remember that our units for volume here would be centimeters cubed.